Thank you very much. First of all, let me tell you that I'm very excited about being with you today because for me, it's a totally new world. We are on the edge of these advantages, all this new discovery, and all these conversations. So I am very thankful for being with you, and thank you for sharing all the times and the conversations that I have been having during all day. So one of the things that I have been gonna be talking about is like, what is Microsoft vision about quantum computing, and what is the things that we are gonna be doing for? And when we start thinking about how we are accelerating this scientific discovery, it's not only about quantum computing. It's about the things that we are doing with quantum computing and the applications that are gonna be relying on this quantum computing. Networking is gonna be some of the things that are gonna be also changing how we are interacting with the technology. But the most important is to think about what are the kind of things that you're gonna be able to solve when you are talking about quantum computing. Quantum computing is gonna be great for small data problems that needs to have a polynomial quantum speedup. If you think about that, the kind of things that are gonna be having the biggest impact are gonna be related with science, things that need to do about the quantum mechanics, quantum physics. And that's why we are focusing more on the scientific discovery, thinking about chemistry. Because 96% of all the manufactured goods rely on chemistry. And if you think about that, the impact that they have is gonna be in all the humans. And to solve this problem, we believe that it's not only about quantum, it's about using all the different technologies that are gonna be helping on this discovery. And by putting together AI, HPC, and quantum, we are gonna be able to start creating these new solutions for problems that has been forever in the things that we are doing now. So when we start talking about a scale, in order to be able to create something that is gonna be really at the industrial scales, we need to have more than 1,000 qubits entangled. And thinking about these levels, the first level is about foundational. It's about the basics. And we have been hearing about the NIST computing, but right now we are mostly on the level 2. And when we talk about this level 2, think about having like 100 to 50 to 100 entangled qubits that are gonna be able to start providing information that is gonna be really meaningful for science, that is gonna be providing faster results than the classical computing. And when we're talking about going to scale, we are talking about these thousands of qubits. Now, these resilient systems are gonna be the ones that are gonna be giving you the insights about how these quantum computers are gonna be providing more accuracy in the systems when we are talking about the scientific discovery. And let me tell you about what we're talking about when we are saying that Microsoft is focused more on these reliable logical qubits. And let me tell you a little bit about how we are working together with our partners. Microsoft is not only building our own systems, we work with our partners in a way that we can start discovering these together. And one of the things that we have been doing with Continuum is that we just announced in April that we were able to achieve 4 qubits, logical qubits that were entangled. And the breakthroughs were amazing because we were able to have a correction system that was capable of detecting and correcting the errors at the same time. But the most important thing happened in September when we were talking about having these 12 qubits entangled, because what happened there is that we were able not only to create these qubits entangled, we created a solution that was able to run using AI, HPC, and quantum together. So it was really an application using quantum to discover a new material. So it's not something theoretical. In this moment, it became a reality. What we announced in November is that we were able to create 24 entangled qubits with atom computing. But that's not it. We were going a next step. And what we are announcing is that now, together with atom computing, we are going to start delivering this solution together with them in a way that they can have a system that can detect and correct the computing, the qubits, in a mode with the highest fidelity ever possible. And the other thing is that atom computing just announced that they are going to be able to produce more than 10,000 physical qubits on the same system. That achievement is going to allow us to create more than 100 logical qubits with our error correction system in place. So this is huge, because we are talking now that we are going to be just one step farther to get closer to have this industrial quantum system ready. Now, let me talk a little bit about what Microsoft is doing in the quantum space. We have been talking about the work that we are doing with Quantinuum and the work that we are doing with atom computing. But inside of Microsoft, we have been working with two main issues. The first one is we are working to have topological qubits, and the other one is using Majoranas to have a better results on the information that we are producing. So the idea is that using these logical qubits together with the topological qubits that we are working on, we are going to have the capability of reproducibly create Majoranas and being capable of read out this information from the Majoranas. And this is going to give you the best advantage of the things that we want to do next, creating these applications that are going to be able to change the way that we start discovering new materials, working with drugs, or helping the industry to discover how this can be changing the way that we are doing the things. Azure Quantum Elements is going to be helping us to accelerate these molecular simulations using HPC and AI, because what we are doing is like we can understand using AI models and our systems that we have been working on, like GenMatter, that is an AI model that allows us to identify which properties can we looking for inside of a model, or MatterGen that can help to understand how it's going to behave in the real time a new molecule using these systems. These new applications are going to be using high-performance computing for start running the simulations that needs a lot of information. And together with AI, we are going to be able to start identifying which simulations are going to be the best ones that we need to run in systems. And that's the moment when quantum computing is going to come in, because quantum is going to be focusing more in getting the best accuracy on the results that we got, not at atomic level, but at the electron level. And this is what we are doing inside of Quantum Elements. Azure Quantum Elements is going to be focused on how can we unlock the power for the researchers to start working in creating and identifying these new systems. The most important part is like by integrating AI, HPC, and the power of quantum computing, we are going to be able to accelerate this, and we are talking about moving from 250 years of chemistry and reduce it to 25. So that's the biggest advantage. And one of the examples that we have is the work that we have done with the Pacific Northwest National Lab to identify how can we create a new electrolyte that can be used 70% less lithium. So we started analyzing different combinations from the periodic tables, and we were able to get 32 millions of different candidates. These 32 millions, using AI, we can start thinking about what are the properties that we need to find inside of this electrolyte. When we identified these properties, we were able to start screening that using high-performance computing to reduce the number of candidates that can be used. And we were able to go from 500,000 to 800 candidates. And then we start doing molecular dynamics around that to identify the 150 best candidates. Then, with that results, we were able to provide 18 candidates. All of this job took only 9 days. That's the power of putting together high-performance computing together with AI and quantum computing. All of this process to discover this battery was able to create the battery in 9 months. So this is a reality. This is not something that theoretically functions. It's something that works now. And we have been working not only with our partners in the Pacific National Lab. We are working with companies like AkzoNobel, Jason Mary, Unilever. Many companies are already using these systems. And we are in a private preview now, and we are working with customers that want to start having these advantages now. The good thing is like everybody now can subscribe to the private preview, and we can start working with them in not only the quantum computing, but the entire Discovery Suite. So now let me show you another video that is going to show you what is the vision of the things that we are going to be looking for when Azure Quantum Elements it's at the scale and we are talking about in the next 8 months.
AI for science will redefine the scientific discovery method. Let's see it in action with Azure Quantum Elements, which will democratize AI for chemistry and many other scientific fields. As a chemist, I want to find new molecules for a new, environmentally friendly immersion coolant for data centers. Copilot analyzes both research literature and my company's internal data and returns 2 molecular starting points. Copilot also suggests another property and designs the computational workflow. This workflow starts by generating thousands of candidate molecules matching the properties I've identified. These candidates are screened with AI simulation and then with accurate calculations using HPC. I can customize this workflow and add new steps to it. With future quantum integration, I will be able to leverage the power of a quantum computer too. Copilot returns the most promising candidates once computations are complete. Copilot goes further, analyzing these results to make a recommendation for the next iteration, enabling a continuous reasoning loop with the scientist. I can now send the simplest pathway to my lab to synthesize and test this molecule, whether it is a new drug, a better battery, or in this case, an environmentally friendly coolant for data centers.
What I just showed you is something that is real. What we have seen now is a real coolant that we are working on for our data centers. Another thing that is very important is when we start talking about quantum computing, we are talking about how can we make quantum safe? How can we create this responsibility together to help our customers to be secure when we are talking about cryptography? And we have been working in creating this new environment that is called quantum safe. So you can go there and identify if your systems are going to be quantum safe when we are talking about quantum cryptography and things that can be harmful. And the other part is like Microsoft has been participating with many different bodies around the world to be able to provide these insights and helping them to create a better world. Now, one of the things that we want to do now is invite you so you can learn more about the things that we are doing. What is the things that we are doing with Azure Quantum Elements? What are the things that we are doing with our topological approximation to the quantum computing? And you can try the Copilot now for chemistry. You can go there and start asking questions about quantum elements and get access to the site and the information that we have online. With that, I really appreciate the time, and thank you very much for having me.